trees and counting techniques. We have considered the number of ordered arrangements of n object taken as an entire group. What if we don't arrange the entire group? Specifically, we consider a dinner party for 8 and found the number of ordered seating arrangements for all 8 people. However, suppose you have an open house and have only 5 chairs. How many ways can 5 of the 8 people seat themselves in the chairs? Okay, let's see what that means. The formula we use to compute this number is called the permutation formula. What does that mean? As we see in the next example, the permutations rule is really another version of the multiplication rule. So, counting rule for permutations. The number of ways to arrange in order, n distinct objects, taking them r at a time, is denoted PNR is n factorial over n minus r factorial. The point to remember is for a permutation, order matters. You are arranging things in order. Okay? So you are choosing r things from n things in order. N and r are whole numbers. N is bigger equals r. Another commonly used notation for P and R is NPR. In calculators, typically you see this button, okay? Regardless, NPR is same as PNR. Let's compute the number of possible ordered seating arrangements for 8 people in 5 chairs. So you see there are 8 people and only 5 chairs. But you are also ordering them. That is chair number 1, chair number 2. Order matters. So from a total of 8 different people, we wish to arrange for 5 of these people. So instead of P and R, you now have P8, 5. So where you see N, you will plug in 8. Where you see R, you will plug in 5. 8 factorial over 8 minus 5, that is 3 factorial. 8 factorial means 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what factorial means. You count down from 8 until 1 and multiply them all. You get this number. 3 factorial means you count down from 3. 3 times 2 times 1. When you multiply, you get a 6. When you take the quotient, you get this number. So there are so many arrangements. Chair, there are 5 chairs. First chair has 8 options because there are 8 people. Once one person is given chair number 1, chair number 2 has 7 options, 7 people waiting in line. Once these 2 chairs are taken care of, there are 6 people left. So you see this is nothing but a multiplication rule, 8 until 4, and you get the same answer, 6720. So permutation is nothing but multiplication rule. The permutations rule has the advantage of using factorials. Why? Because most scientific calculators have a factorial key as well as a permutation key, NPR. Now, in each of our previous counting formulas, we have taken the order of the objects or people into account. However, suppose that in your political science class, you are given a list of 10 books. You are to select 4 to read during the semester. Any group of 4. All right? The order in which you read the books is not important. That's what you are told. You have to select 4 to read during the semester. Order is not important. In this case, we are interested in the different groupings or Combinations. When you collect a group without caring about order, that's what is a combination. So you want to choose four from 10, choosing 4 books from among the 10 on the list. So the next formula shows how to do this. CNR. This is number of combinations of n objects taken R at a time. The point here is for a combination, order does not matter. So the formula for this is n factorial over r factorial times n minus r factorial. N and r are whole numbers, n greater equals r. So this also there is a calculator key if you like. That's your formula. Other notations for CNR are NCR and parentheses N sub R. Okay, they all mean the same thing. And the formula is given here. Let's look at an example. In your political science class, you are assigned to read any 4 books from a list of 10. Order doesn't matter. How many different groups of 4 are available from the list of 10? In this case, we are interested in combinations rather than permutations. Repeat, if order matters, you look for permutations. Here, order of the books does not matter, so you're looking at combinations. So you are looking at CNR, C10, 4. N is 10, R is 4. And substituting, you get 10 factorial, 4 factorial, 10 minus 4, 6 factorial. And let's see, eventually you get 210. There are 210 different groups of 4 books that can be selected from the list of 10. An alternate solution method is to use a combination key, NCR or CNR, on a calculator. Okay, if you don't wish to use this formula, you can use a calculator using these keys. Now, procedure, how to determine number of outcomes of an experiment. If the experiment consists of a series of stages with various outcomes, use multiplication rule or a tree diagram. Use tree diagram or multiplication rule when you have various stages to go with. If the outcomes consist of ordered subgroups, so you want to choose R things in order, use the permutation rule. So ordered subgroups of R items taken from a group of N items, use the permutation rule PNR. PNR formula is N factorial over N minus R factorial. The last option, if the outcomes consist of non-ordered, that is, order does not matter, subgroups of R items taken from a group of N items, you would use combination rule CNR. CNR is given by the formula N factorial over R factorial times N minus R factorial. So it's quite similar to this, except there is an R factorial in the bottom. Okay, so that completes the theory for section 5.3. Our next videos will cover problems from section 5.3. Until then, bye.